Is the sound okay? Great. Okay, I think actually a little bit of false advertising here in the sense that I'm more of a bridge between what you just heard about and I think what David, for example, will be talking about now. We were just talking over the break, really getting into the water pricing issues and some of the institutional things. So I think you can see this as a bit of a bridge. And indeed, if you look at the authors, you can see that this is a bridge between economists in the top row and hydrologists in the bottom row. Okay, yeah. So this is a collaboration with hydrologists at the University of New Hampshire. It was actually just a year ago where I was at a meeting with Richard Lammers from the University of New Hampshire, and we were brought together at one of these meetings where the interdisciplinary, you're supposed to get interdisciplinary. Well, it was, there was a lovely reception, and we started talking, and we said, why don't we take that economic model that we've been using and put it on a grid, a global grid, so we can interact more meaningfully with their global hydrological model. So we've done that. Here's some kind of a first paper out of that. And there's some, I think, economic insights, some emphasis on trade-offs, and certainly relating also to the Sustainable Development Goals. So I think it fits in nicely with the theme of this conference. This is an overview of the talk. So I'll be focusing on agricultural irrigation. I will adopt a definition of sustainability that goes back to, in fact, the missing speaker, Alcamo. And we'll talk about the consequences of attempting to achieve sustainability in water, the consequences for food security, carbon, and you could think other sustainable development goals as well. Inevitably, they're trade-offs. So we'll be using this economic model to analyze both project future sustainability or lack of sustainability and talk about the consequences of trying to achieve that. So we've heard a bit about groundwater, why it's such a popular thing. This really underscores that, and this highlights, I love this slide because it shows how, with the advent of the Green Revolution, these new technologies that required, in fact, intensive irrigation and fertilization to realize their full potential, groundwater just took off in India, rising strongly elsewhere as well. And it just reinforced the points made in the earlier talk that groundwater is terrific because you can go and get it whenever you need it, and it's rather drought resilient. At least that's the assertion by Burke and Vilhoff. So strong growth. Unfortunately, it's often been in areas with low recharge rates, and that's the problem. Here's Yoshi Wada. Also, his work was he's a collaborator with Carroll. In that previous talk, this is his 2012 paper, estimating non-renewable groundwater abstraction for irrigation in the year 2000. So you can see that, of course, subject to all the difficulties and limitations of estimating recharge and the data on withdrawals, but this is his best estimate of that. So it's pretty widespread. How is that going to evolve in the future? For that, we're going to work with this admittedly arbitrary threshold. We're going to be concerned about cases where the amount of irrigation withdrawal exceeds 20% of water available for irrigation. How do we compute that? Well, discharge plus storage plus soil stored water, so these are the reservoirs, soil stored water minus non-agricultural uses and livestock. So it's by deduction. The denominator is by deduction. So in our economic model, we'll project this forward. This will be coming, because it's a partial equilibrium model, this will be coming from the hydrologists without any interaction at this point. So we're interested in how that ratio will evolve, that index will evolve in the future. So here's the model that we've developed over the last year, and I'll also show you where we want to go with that. This is the UNH hydrological model. I'll talk about that in a moment. And here's the economic model. It's called simple, and because it is simple, and I'll talk about that as well. So right now, we only have this one-way flow from irrigation availability here, we need to incorporate this feedback, and we've just got a 5-year project funding for 5 years to flesh out the rest of this framework. So this is a cartoon of their model. I'm certainly not qualified to speak to their model. All I know is that I'm learning about it over time by digesting the output and also suggesting improved inputs in some cases. But it's got flexible grid size. That's important for communicating with us, a daily time step. And that's important for the, as we'll see, we'll be talking about climate impacts on irrigation demand. It also factors in reservoirs, interbasin transfers. We're going to explore that a little bit as well as a potential vehicle for sustainability. So the water balance model communicates to the economic model through these subbasins. So they've grouped together grid cells into subbasins, and this is the global map of subbasins. The colors just are intended to prevent spillovers. They don't mean anything here. That's just a visual on the subbasins around the world. And this is a zoom in on South Asia, actually showing the modeled rivers and streams within each subbasin. So the idea when we go to the economic model is that within the subbasin, that we're concerned about water scarcity, not at the grid cell level, irrigation scarcity, but rather at the subbasin level. Because if it's a little scarce here within the subbasin, you'll just let more flow downstream, or, so the water is assumed to communicate within the subbasin, but not across subbasins unless there's an interbasin transfer. So it's stylized, but that's the way it's set up. The economic model, this is a model I first developed for teaching purposes in an interdisciplinary course, and we've had so much fun with it that we've been using it a lot in research. And you'll see some of its advantages at work momentarily. But it basically, the simplest possible model you could think of for thinking about global sustainability of the food system. This is a simplified international model of prices, land use, and the environment. So we worry about land use, we worry about terrestrial carbon emissions, emissions associated and pollution associated with non-land inputs like fertilizer. This was initially developed as a non-gridded model, so in the rest of my life, this GTAP life that I used to live in, of general equilibrium modeling, we were constrained to work at the national level. I realized once we started working with a simplified structure, we could put it on a grid, and that was the conversation with Richard Lammers. Why don't we do our modeling on a grid? And so rather than having an aggregate supply function for the United States or for Britain, it's gridded production, the same production structure. This is kind of an obscure way economists show the production structure, the inputs producing output, but they're basically in each grid cell there's irrigated and rain-fed cropland, and they compete for land, and irrigation water comes in here. And if you want to know how much production's available in the UK, you sum over all the grid cells. So it makes perfect sense for biophysical modelers. It's not common for economists. Another thing economists don't do much of is hindcasting. So because I've been working a lot with climate scientists, we've worked hard on that, focusing typically on this period. It's a period just before the commodity boom, going back to the start of the FAO data. It's hard to go back before that data-wise. And this just shows the performance of the non-gridded simple when we just shock population income and productivity growth by region. And it's remarkable how well it captures this very important fact that over this period we tripled output, but most of it came from yield, not from area, on a net basis. And prices fell over this period, as Tony Allen indicated. So really a remarkable performance of this system. Some of the environmental consequences notwithstanding. Here's the performance with respect to cropland area. One thing we found as soon as we started doing this historical analysis, distinguishing rain-fed and irrigated areas, is there's no way you can explain the strong expansion in irrigated area over this period without allowing productivity growth in irrigation to be faster than rain-fed. It makes sense. The India example, that was all about irrigated technology. Also, increases in cropping intensity, in a sense, translate into productivity increases. If you can grow a crop twice on the same land through irrigation, productivity is higher. So this productivity increase, I'm going to show that that's very important historically, very important in the future as well. So these are projections to 2050. So the argument is, well, if you can go back in time to 1961, not do too poorly, maybe you have a hope of going forward. Projecting, the global economy is a risky business, but it's worth thinking about, and I think particularly in a scenario context. So Alexandratos and Brunsma at FAO, very influential study in 2012, in the middle of the food crisis. They projected total cropland up to here, increasing up to here, and they have a remarkable slowdown in irrigation. If you look at the historical trend, that's really striking. When we run the model, our model, assuming no productivity differential between rainfed and irrigated, we get actually more irrigated more total cropland, about the same irrigated area. This turns out to be, I think, largely driven by the fact that the current baseline scenario for integrated assessment has more robust income growth in the low-income countries, more food demand growth, and I think that's what's driving this difference. But actually, our baseline with equal productivity between rainfed and irrigated is very similar to the FAO. Look at what happens if you impose that historical productivity advantage for irrigation going forward, okay? You get more irrigated area. Of course, the irrigated area is more productive than the rain-fed, so you have flat to declining global cropland. So what happens in irrigation is important in terms of how much total cropland you need in the future. And this productivity, I haven't heard, I'd be interested, it's just something we've kind of stumbled across, our own little discovery in trying to do the backcasting. I'd be interested in more feedback as to other people who've measured that. So most agricultural economists measuring productivity can't make that differential. So sustainability in 2050, how will it look in the future? Here's a projection, simple projecting the global economy forward. Population, income, exogenous, projected with SSP2, or the base business as usual from the integrated assessment community, equal rates of productivity, and importantly, you'll see RCP 8.5. So projecting sustainability for the water system depends critically, as you'll see in a moment, on the climate outcome. So if you move to a more sustainable climate scenario, you have a different sustainability scenario for water in the future. So this is the story. This is areas that were in deficit and become more of a deficit, and those mean the denominator's negative, the net availability for, they're already drawing down groundwater, depleting the groundwater, and net availability is negative. These become unsustainable in the future, and some other changes. This just shows that according to this scenario, this projection in this model, obviously it's one possible draw, not all areas become less sustainable. Some become more sustainable. The green areas become more sustainable. Why? Rainfall increases here under this RCP 8.5. So more rainfall over the Ocalala, more recharge, more sustainable future. So in that small slice, also factoring in there, does factor in temperature effects on crop growth, that they become more sustainable. Let's explore the sensitivity of this sustainability index that I talked about earlier on. So this is the index of irrigation over net availability for irrigation. Does it go up, improve? Green is better. Better means actually, yeah, the sustainability index actually. Irrigation as a fraction of that goes down. So green is better, just remember that. Green's better, red's worse. And the thing you notice here, if you go forward with more productivity on irrigated lands, an economist might think initially, well, that's good. You'll probably be more sustainable in the future. That's not the case here. Why? Because they're more productive, they're more profitable, they expand irrigation. Less rain-fed, more irrigation. So that's what's going on, say, in much of South America, and the Near East and so on. So it isn't obvious in this framework, which is a simple kind of a data-driven framework, it isn't obvious which direction this will take you. I did say before that total cropland use will be less under that scenario. But the sustainability metric in terms of water is unclear. this shows the interaction with climate. Okay, so RCP 2.6, that's a dream scenario in terms of climate mitigation. So in this century, climate temperature stabilizing. Okay, so all those precipitation effects you heard about earlier on are less prominent. You see here actually now, relative to the 8.5 scenario, less sustainability in that region. Why? Because less rainfall. Okay, so there's this interaction. I'm not saying that RCP 2.6 is bad. There's many, many good things about mitigating climate change. It's just that in this particular case, with less rainfall, in that particular set of subbasins, less rainfall means less sustainability on this narrow metric. Other metrics, obviously, the world would be a lot better place with under 2.6, but it just shows the interaction. Okay, let's, I just want to, in closing, I want to wrap up focusing on consequences of sustainability policy. So we're just starting this process, and this is research in progress, paper in progress, but so for this sustainability scenario, we did the simplest thing we could think of, and that was if you have a grid cell that is showing a metric above this 20% threshold, you take enough irrigated area out of production. Okay, we're not changing efficiency. Just take enough area out of production to bring them back down to 20%. So bring them back down to that threshold. So that's our sustainability policy. So we aren't really doing a policy here. We aren't. It's more like central command. Okay, but that's an interesting thought experiment, and we do it under 3 scenarios: business as usual. So that's SSP2. SSP2, but in the presence of interbasin transfers that the hydrologists have said are on the books, could be implemented over this period, and in the presence of enhanced global trade. So this is the experimental design. Start in 2006, run out to 2050, business as usual. From that base, do a sustainability policy. Start 2006, do a different simulation in which you're implementing these interbasin transfers. You're connecting those subbasins. In that case, you end up with a different 2050. Do a sustainability scenario off of that. Finally, do one with integrated markets. This is a very different world. This is a world where there's one price for crops worldwide. Think microchips, okay? Take away all of those barriers to agricultural trade that agricultural trade economists like myself have complained about for years and seem awfully persistent. Although it's remarkable how in the presence of global supply chains, even agriculture is reforming even unilaterally to get to participate in those supply chains. But this is a nirvana, unrealistic perhaps case. Even this is unrealistic. Those interbasin transfers, probably some of them very expensive. But let's see how they interact. So this is looking at the interaction. These are the different scenarios that we're doing, those 3 scenarios. Here's one metric. Undernourished population in thousands of persons, so this would be 400,000 here, and this is an increase relative to 2050 baseline. So in 2050, you've got a certain number of people undernourished in South Asia. How would that increase with the increase in crop prices that follows from the sustainability policy? Obviously, any restriction you put on agriculture is going to boost food prices. We were talking about that in the last session. So there's a trade-off here. Okay, so the food price increase in South Asia depends on which regime you're in. The integrated markets has the least price increase. Why? Because South Asia can source their products from elsewhere very easily. The highest increase is the business as usual. Africa, sub-Saharan Africa, is a very different scenario. It's kind of, in this case, actually the integrated markets, in that context, the sustainability policy has a bigger increase in food price in Africa and a bigger increase in undernourishment. And this, the point came up in the last session, very little irrigation in Africa, so not a lot of unsustainable irrigation presently. So the main effect they get is from other countries, from what happens in South Asia, what happens in the US. If they're kind of protected from those regions, okay, can be bad for consumers, they don't access the cheap stuff, but if those regions do something like a sustainability policy, they aren't affected as much. They are affected a lot under integrated markets, and that's what's going on there. So interaction between sustainability in water and nutrition, nourishment, undernourishment. Here's the other regions. Don't have time to talk about them. The last metric we have relates to terrestrial carbon fluxes. We're still sorting this one out, but this is the cropland cover change under integrated market scenario. Cropland cover change around the world as a result of the sustainable irrigation scenario. So equal productivity growth up to 2050, RCP 8.5, integrated markets. This is the change when you do that sustainability scenario. So it gets moved around. Production gets moved around, cropland gets moved around. What does it do to carbon? Well, interestingly, it depends on the region you're in. In some regions, this is good. Negative is good here. These are emissions. This is sequestration. This is increased emissions. So in Africa, what happens is you've got under integrated markets, you've got other regions really constraining irrigation. World prices go up. Integrated markets, African producers see that price increase and they respond. What are the characteristics of agriculture in Africa? Low yields, and low yields especially relative to carbon, terrestrial carbon. So they convert more land, and they convert quite a bit more land to fill that gap that's left when US pulls back, for example. So you got more land conversion and relatively carbon rich, and as a result you get emissions rising in the region and tending to push up global terrestrial fluxes. South Asia's the other way around, however, and we're trying to figure that out, why that is, and Jing was just sending me some emails. We're computing a Pearson rank correlation between cropland change on the one hand and carbon stocks on the other, and by region. And so it turns out that in South Asia, there's a negative correlation, okay? And that's what's leading to this decline in terrestrial fluxes there. In Africa, there's a positive correlation. So you're getting more expansion in areas that are more carbon rich. So it seems like this is it's kind of region and grid cell specific. We need to understand that more and find out, see if that's a robust thing. So let me wrap up here and just say under the business as usual scenario, so it's SSP2 for those following the IPCC now, unsustainable irrigation increases in many, but not all regions. Becomes more sustainable in some regions. Why? Partly because of precipitation. Partly there are other factors the hydrologists tell me, and I haven't fully dug into those yet. But that's the dominant one. The evolving irrigation vulnerability index, that so irrigation withdrawals relative to net availability for irrigation, that how that evolves, first of all, it's quite varied, but how it evolves really depends a lot on this relative rate of productivity growth, irrigated versus rain-fed crops. I'd like to hear more from the other economists and others. What do we expect about that in the future? The climate change scenario also affects this vulnerability index and in the future, and hence the extent of a sustainability scenario. They vary by subbasin. Impact of sustainability policy that we might consider in the future, and I just looked at a really simplistic one, but I think any policy you would consider, turns out that's going to depend a lot on trading water between subbasins, that's an interbasin transfer, or trading commodities, which I think you could argue that agricultural protectionism notwithstanding, that in 2050 it's very likely that the world will be more globalized in general, and even agriculture will be more globalized than it is now. And so these are going to shape the way we think about sustainability policies in the future and maybe change even our intuition. I'll stop there.
Yeah, thanks a lot. Well, thanks indeed, Thomas. Really excellent. Your last remark reminded me of a mistake I made, and I fully apologize. I should have mentioned that you are also called to be one of the founders of the GTAP modeling platform, which is one of the most commonly used international trade data-based macroeconomic modeling platform, and that's indeed quite relevant. But thanks also for referring to the term of market integration, which is something that most European economists and most European researchers should know about, because this is at the heart of the European market integration, well, a topic that is, well, somewhat very topical these days here in the UK, as you can imagine. The floor is now open for you coming up with questions, comments you may have on Thomas' presentation. Yeah. Please introduce yourself. I could do it too, but you better do it yourself.
Hello, so I'm Victor Nekifor. I'm a PhD candidate here at UCL ISR. And I was wondering, in addition to the 3 scenarios to achieve sustainability, whether you ever considered water permits, since this is a water market session, whether that would be feasible in the time horizon of 2050 as a solution.
So, excellent point. And I was kind of underscoring that all the policies we're considering here are very stylized. And really, when it comes to permits or any other policy, certainly a policy affecting water, it's going to be highly variable by region, by locality. Look at the United States. How many groundwater in particular, there must be a dozen or more different types of regulations governing groundwater. It varies even within states within the U.S. Huge variation in how it's regulated. And so in the end, it's going to require huge variation in the way we think about it and the way we endeavor to take reforms. I think in the next talk from David, you're going to hear some about the Australian experience, particularly in the Murray-Darling Basin. That's one example. But I think permits potentially a very important mechanism for getting this scarcity effect in there, for getting a quasi-price in there, which I certainly advocate. But at this global scale analysis, this is very simplistic, that's all. Yeah.
Hi, my name is Shalu, and I'm a master's student here at UCL. So in one of your scenarios, which is integrated markets, one of the results was that sustainability increases in South Asia because South Asian markets would start to import food, like commodities, from the global market because of the food price rise. Have I understood it correct? Yeah. So
I'll clarify that, and then you keep going. What this shows is that the price rise from a sustainability policy, starting from the same point in 2050, actually maybe starting from a slightly different point, but the price rise from a sustainability policy in 2050, trying to implement the sustainability target in 2050, is less under the gray integrated markets, and it's less because they're able to, if they're constrained in terms of how much irrigation can be done. You saw the groundwater curve in India. If you bend that, start bending it or even bring it down, more imports may be required. In this scenario, integrated markets, it's easy to get that. And so that's, yes, you're right. I just wanted to. Yeah.
But I was just wondering, in general, if we look from political economy perspective, so whenever there are price rises, governments in South Asia would respond by giving more irrigation subsidies. And
sure.
So, how would it go well with the assumption that you decrease the irrigation footprint, in such a scenario?
That's a really good point. The irrigation subsidies, we've been talking about the problem of not pricing water, but add to that, at least in Nebraska, they have to pay for the energy to pump this out. In India, the electricity is highly subsidized, so you've got a double whammy, and that's part of what's driving that tremendous increase in groundwater. That's right. We've, in a separate study, I didn't mention it here, this was led by a collaborator, Farzad Tahirapur, with the World Bank, focusing on South Asia. We found that if you reverse the political winds somehow, which might be very difficult in India, but you took the money being spent on those irrigation subsidies, invested those instead in efficiency enhancing technologies. So keep the money in agriculture, but rather than in this perverse way subsidizing the power, if you invested that into improved technologies for water efficiency, you could have a big bump in GDP, and would be a really good outcome. So there's so many ways you could improve on the current system, and you're right that even more adding more subsidies on that would be a disaster. Yeah.
Andrew Ross from Global Garden. The European Union Non-Financial Reporting Directive has been a platform for the development of the natural capital accounting and the natural capital initiative, which corporates are adopting because of their supply chain vulnerability, which is, of course, in many cases global. But they are under very great pressure from the financial institutions to account for their whole supply chain vulnerability, particularly water. And the Carbon Disclosure Project, CDP, has a whole water valuation metric to enable bonds, such as water bonds, to be developed by corporates to invest in local sustainability. Now, this could be a financial feedback mechanism that is not entirely connected with the commodity price of rice or wheat, maize or other commodities. It's an internal matter that major corporates are implementing in their own shareholders' interest, the pension funds and the insurance funds who are their investors. Have you introduced or brought in natural capital protocol and natural capital initiative accounting in your thinking?
Sure. I mean, I haven't at this point. I think it's a really good point, and I might use even a different framework for looking at that. The GTAP framework, for example, tracks who's trading with whom, where is the product coming from. This framework's not doing that, but that's what you need to flesh out that supply chain. And the question, of course, is how, okay, the concept's good, some people are responding to that, can it be implemented, will it have an impact? I guess in its favor, one could look at the Brazilian example with deforestation. Part of the explanation for that rapid slowdown in deforestation in Brazil, of course, there was the remote sensing, there was the a lot of things, but part of it was through the private sector, the supply chain, asking for the corporates, as you say, asking for certified deforestation-free soybeans, and that's had a measurable impact according to people who studied that in Brazil. So if that could be transferred over, it's hard to measure water, but it's also hard to measure deforestation, at least in a serious way. I mean, you can see the forest being cut down, but what's causing it's another thing. Groundwater's certainly probably a more difficult challenge, but that's reason for optimism, I guess.
There's a framework to do it.
Yeah.
The water protocol.
Okay. There's a framework, but what about the measurement issues and so on? That was the challenge in Brazil, but they've set up the private sector has set up supply chains just also for GMOs, GMO, non-GMO. So they've proven even for bulk food products, they can segment the markets, they can differentiate along those lines and can benefit from that. So I don't have a lot to add to that. It sounds like you want to give the talk on this, and that's good. I don't know much more about it.
It's the insurance market with a commitment
Sure.
to invest at least $1 trillion a year to meet the 2-degree climate change. And they can't find a project. And that's their attention on corporates who are issuing bonds that they can then invest in. So there's big money trying to find a way to do this.
Good.
I'm sure it will become interesting. I supervised the master thesis myself of somebody working with the CDP data on how this internal water pricing mechanism starts to work. It is very early, so there is not much experience, but it's probably one of the coming issues within corporates. But still, what we need to see from the research side is actually what you say, is what type of methodology would these companies use to do water pricing, and whether it's also applied like in food chains. It's probably easier in manufacturing in a way because they are more streamlined, the value chains there compared probably to the food value chains. And I'm looking forward actually to Louise Bracken to say a bit more about food value chains in a minute, say in 1 hour. Thank you. I'm not here.
Hi, my name's Francesca Harris. I'm from London School of Hygiene and Tropical Medicine, so a slightly different stance on things. I'm a public health nutritionist, and as you're talking specifically about Southeast Asia, or South Asia, China, massive topics in this, and dietary change is, you know, we're seeing it now and problems on that side. But I wondered whether at any point in your scenarios are you considering potential diet change or change in food consumption patterns and the effect that they will have on different irrigation patterns, for example, wheat and rice in India, etc.
Sure. I mean, I just came from 2 weeks ago. I was in Beijing for the Global Land Project, or Global Land Program meetings, and there must have been a dozen papers on diets and land use, and by implication irrigation, and several plenary speakers addressed that. There's a lot of interest in that. As an economist, you know, my concern there is, yeah, it's great if everyone, you know, I ride my bike to work. If everyone rode their bike to work, it'd be a much better world. But are they going to do it? Probably not in the States. So how do you get, you know, changing diets could have a huge impact on resource use around the world, but how will you motivate that? I would say that the best way to motivate changes in diets is, again, through the pricing mechanism. If the food becomes more expensive, they substitute away from it. The food that becomes more expensive when you price water are things like beef. In fact, in the US, with that price spike in grains, feed grains and so on, beef prices went up by probably 20, 25, 30% relative to other meats. Consumption dropped, per capita consumption dropped, you know, 15, 20%. It dropped a lot. So some will say, oh, it was because I was saying it was bad. You know, people finally figured out it's bad for them. No, no, no. I'm convinced it's the price effect. So I think, yes, diets are critical, but how do you get at that? How do you change diets short of, you know, the generational changes happening over decades? I think it's the economic.
Well, there was, as far as I know, a study released by Chatham House a while ago, like half a year, 1 year ago, where they did a survey on how you could make it happen. And indeed, the survey is based on questionnaires and interviews, and you may think it may not happen that way in reality, but nevertheless it was interesting in that it revealed different attitudes to changing diets also across countries. And you seem to be nodding, what seems to me, you know the study, so it's just an interesting piece of research that they did here.
If I may just add quickly,
Sure.
I mean, more in terms of, obviously we have a developing diet, sorry, the developed diet in inverted commas, but the changing diet from the rest of the world to that increased meat consumption and the increase of saturation, or whatever it is, but the increased consumption of food, not just the back to the healthy one. I mean, more the implications of that on water use and water availability.
That's in here. We have diet upgrading in the projections. So people are basically doing what they've done in the past. That is, when at the very low levels of income, they upgrade their diet and you see more meat and more resources for that.
Two quick more statements, Carol.
Yeah, I think that was my question because. Yes, thanks for the great talk. I actually wanted to talk about that as well. Like, how do you integrate in your scenarios the demand changes in terms of diets? How? But you just answered a little.
That income elasticity of demand that's somewhere up there at the top, that is, give someone more money, how will they spend it? That evolves as a function of per capita income. So it starts out high for food products and especially for meats, and then eventually falls. And also the calories purchased per dollar evolve, become less over time, and there's a shift, an upgrading of the diet. So there's actually multiple food products here.
Okay.
And
Thanks.
One more, make it quick, please. Thomas, you seem to fascinate the people here.
Or irritated at one thing or the other.
Hi, I've just come into the conference today, so I've missed a few hours of your talks. But I just wanted to mention I'd been at a campaign organization conference a few weeks ago, which was about the issue of the BHP bulletin in Brazil. So as you know, Raymond, I do ask this question to you every year. I'm quite pertinent with it as well. The issue of water and the issue of the amount of water it's required to dig up the minerals in Brazil. And we all know what Dilma did in Brazil. Same things happened in Jharkhand, in India as well, in many other countries around the world. Even in the Dakota land as well, that requires a lot of zinc for wind turbines. So my question is, with regards to the more pertinent issue for me, not so much about water per se, but while the UCL is continued to be sponsored by BHP, is that tenable to carry on like this and then talking continuously about sustainability of water? When is that going to stop? I know there's a lot of universities that are sponsored by corporations, but this duality is just baffling me. Please, someone answer that.
Well, thanks for coming, and thanks for seeing you again. Thomas,
It's all
this
yours.
seemed to be not directly a question to you. I would like to respond, but at the same time I would also like to close this part and ask the speakers of the next session to move over here. So basically the question, as far as I understood it, is to what extent there is an issue with mining and water, and I think that's a clear issue. And both mining industries but also researchers are concerned about it. And the Brazil incident was a disaster in many, many regards. Whether it comes to the point of us being continued to be funded through BHP Billiton, there's a straight answer to it, which is no. The contract with BHP Billiton is running out. It's not going to be renewed. And therefore I would say, good period of us being funded through BHP Billiton, for which we have been generous and grateful, this is now coming to an end. So I will be happy to see you again, despite the fact that the Institute won't be funded through BHP Billiton then. If that's enough of a response. Thank you. All right. Then I see David, the next speaker, actually being in place. So thanks again for joining us. I would like to directly give the floor to David and your presentation on optimal water reform strategies. There was already a hint at your presentation done by Thomas, so I really look forward to your 10 minutes.